construction lines. Could add some shading. Make a bit more of a gap than I have. So that then gives you a framework to do simple shapes. This is 3D solid. I haven't worried too much about angles and perspective, but in the coursework I've asked you to do a isometric drawing. I'll go on to that in 1 second. What I want to cover first is something called axonomic drawing. So here we've got some, this is just solids here. Now one of your foundations is going to look something like a square pad with a column coming out the top. So that's going to be the plan view of your foundation. The elevation is going to look something like that. Very broadly. I'll go over it a bit more because it's not coming up much. So thinking about those construction lines and projection lines, can you draw this in 3D? The foundation in 3D? Okay. So one way of drawing in 3D that's quite nice is called Axonometric. In axonometric drawing, we take the plan view, we rotate it through 45 degrees, and then we project it down. So if I'm going to draw this foundation in 3D using an axonometric viewpoint, I want the plan view will be true, and then the others, then extend into 3D. So a good idea to do is to turn the paper through 45 degrees and draw your foundation. I want to have a central column in here. Gauging it can be a bit difficult. Some people are very good at this, some people aren't. If you're not, a good way of doing it is deciding on the side of your line where your centre point is, and then drawing these construction lines across. Oops. And then that allows you to place your central column. I'm going to go back now. So what I've drawn is just my plan view of 45 degrees. That's all I've done. If I then draw some vertical lines down, what's vertical for me? It's not vertical. And what I'm aiming for is a parallelogram, so I want to draw parallel lines to each other. That's why the thing at the beginning was really important, understanding being able to draw those lines together. What I can then do is project the side view onto each side of that cube. So that I've got a plan view on top, and I'm going to draw the side elevation on this face and on this face, because it's the same for both, for this particular one. But it has to be angled now because my face is also angled, the viewing face is also angled. Now's the time to concentrate because you end up with a lot of lines in your drawing now. What I want to do is project that base down. I want to project this side into the box and this side into the box, and where they intersect, and that becomes my 3D axonometric view. So I'll go through that and show you how I do that. The column is represented on the sides here, but it's going to be drawn in the middle. To do that, I need to extend the lines, making sure that I'm staying parallel with the rest of the construction lines for the location of the base. Can then project down for that column, and that places the column. Any of the finished lines I'm going to make bold just to make it clear that they're not construction lines, they are finished lines. I need to project the back of the foundation as well. So I'll take parallel lines back behind the column. And then once again you would get rid of all the construction lines, all the intermediate lines. And you'd be left with an axonometric viewpoint. So for this, what we're doing, we're projecting plan and elevations onto the outside cube, and then we're creating that 3D image within that cube on those projections where those construction lines. Now it is a very simple shape. The beauty about this technique is you can have a very complex shape, maybe a building with a lot of different features, different shapes, and the principle still works. So I do appreciate you can probably draw this without this technique, but this is a very applicable technique for doing more complex shapes. So mastering it on a simple shape is very beneficial. Now for the axonometric view, all of these lines are going to be about 45 degrees. And that's because we started off with our plan, angling that to 45 degrees and extruding that down to create the image. Okay, so I asked you for, I'm going to rush a little bit because I want to get onto the isometric projection. Axonometric, we've got a 45 degree angle because we're using the true plan area to create the illusion of 3D. In isometric sketching, we actually use an angle of 30 degrees to the horizontal to create our construction lines in the horizontal plane. So let's make this a little bit more complicated. One of the foundation designs you need to do will be for the columns that come through the building, go onto the pad foundation, but are also supporting a ground floor slab and a first floor slab actually. But now in plan view that looks something like we've got a central column sitting on the pad foundation, and I also want to represent the floor slab, but just a cutaway section of the floor slab so that we can see how that interacts with the system. So that's my pad foundation, that's the floor slab, and that's the column. In profile, that's going to look like something like that. In fact, it's going to be surrounding the column. So once again, that's the pad foundation, that's the floor, suspended floor, that's the column. Now I want to draw this in isometric projection, but the same kind of principles are going to apply here. I'll go over it a bit more darker as well so you can see. It's not coming up very well. Okay. So we started with a horizontal line at the base, that can be handy. In isometric projection, all the vertical lines remain vertical. And all of the horizontal lines are going to be at 30 degrees. So I'm going to have the corner of my pad foundation here where I put the cross, and I'm going to draw my foundation coming up in isometric projection. For that I need to draw my 30-degree angle line. Now you can pretty much work it out. 45 degrees is about there, 30 degrees is about that. So all the horizontal lines have to be 30 degrees. I'm going to use the same system where I take those plan views and those side elevations and I create the image inside. So the first thing I need to do is create a box that will then enclose my whole system. It's not great. Where did the box of pencils go? Yeah, let me get another one. It's fine. So my construction glass box, you can think of it as a glass box through which you're looking through at the image. I want to put my side projection here and my plan there, so do it along with me. We've got, let's do side first. So we've got the base, the pad foundation, say it's about there. The column, the centre of this line is roughly there. I'm going to go out a little bit either side. That'll give me my column projection anyway. So the column on this side, so centre of the line, a little bit either side. The floor slab, roughly it's about halfway up, so again I'm going to find the centre of my column line on either side and then just draw my floor slab extending out a little bit. In fact, it doesn't do that, it does that. So centre of the line, a little bit up, a little bit down. And then the top projection. Let's extend those column lines. Great, let's try again. If you mark the location on both of the lines, it does help to centre it better. That's better. So anytime you know that you're getting something that's going to be part of the final drawing, it can be helpful to make it bold, just to make it distinct from all of those construction lines, because you do end up with a lot of intersecting lines here. Let's find the base of that column as well. So always maintaining this 30-degree angle for all of those plan lines. The corner of the column is going to be roughly there. And then we do the same for the floor slab. Do you want more paper? I've got some more. Pencil. That's awful. Alright, you can then add some shading if you want to add shading and stuff. And then always get rid of those construction lines. Now, I don't know if I mentioned this, but what you can also do is do everything in pencil, then go over all of the final lines in pen, and then you're able to rub out all the pencil markings as well. So that's probably a good way of doing it, rather than just trying to do pencil on pencil. So it might seem long-winded, but the beauty of this method is, and I haven't done it that carefully here, but if you do it carefully, then you can end up all the correct dimensions being projected at every single point of that object. So it's very valuable. Let's have a look. So this is what I'm looking for in the assignment. Every single type of different foundation you have, you'll only have 2 or 3 different types of foundation. A nice projected view of that.